Today we're learning about creating and graphing quadratic equations using standard form. We've already used standard form to graph parabolas and quadratics in the past, so we're going to quickly review what we already know. First of all, we know that a quadratic equation creates a parabolic shape, or a parabola. We know that there's an axis of symmetry that cuts our parabola in half. We know that there's a vertex that's either the high or low point on my parabola. And we know about Y-intercepts. Let's really quickly review those pieces. So standard form, of course, f of x, or y sometimes, equals ax squared plus bx plus c. Our y-intercept comes from this value of c. If c is a positive 2, my y-intercept is at 0, 2. If c is a negative 3, my y-intercept is at 0, negative 3. Our axis of symmetry comes from the opposite of b over 2 times a. I use this axis of symmetry value to help me find the vertex. X equals whatever number this turns out to be is the x value of my vertex, and then I can plug that value into my original equation for x, and that helps me find the y value of my vertex. As far as the maximum and minimum values go, of course that's going to be our vertex, but a, the value of a, has a lot to do with that. If you recall, if a is greater than 0 or positive, then the parabola opens up, just like the parabola in our picture, and that makes our vertex the low point, or minimum. If a is less than 0 or negative, then the parabola is going to open down, and the vertex is going to be the high point on our parabola, or maximum. Let's really quickly go through an example of finding those values. This example asks us to find the y-intercept and the vertex of this particular function, and to determine whether the vertex is a maximum or minimum point on the graph. Y-intercept is of course the easiest to find of any of these because all I need is the value of c. And since c is equal to a positive 3, our y-intercept is at 0, 3. The axis of symmetry, I need the value of b and the value of a to help me find that value. And we get x is the opposite of b over 2a. If b is 4, the opposite of b is negative 4. And since a is negative 2, my denominator is 2 times negative 2. When I multiply that together, I get negative 4 over negative 4, which of course simplifies to 1. So my axis of symmetry is at x equals 1. Now I can substitute 1 into my original equation for x to help me find the rest of my vertex. I already have the x value of my vertex, but now I need the y value. When I plug 1 in for x, I get negative 2 plus 4 plus 3, and that gives me a value of 5. So my vertex is at 1, 5. Now as far as maximum and minimum goes, a is a negative number that's less than 0, which means my parabola is going to open down, and that makes my vertex the high point, or maximum, on this graph. So now that I have the y-intercept, vertex, and know that it's a maximum, take a look at what this looks like on a graphing calculator. You can see my y-intercept at 0, 3. You can see my vertex over here at 1, 5, and that is for sure a maximum point on this graph. So now we're going to continue finding these types of values, only now we're going to include the X-intercepts. That's really the only thing that's going to be new this unit. We're going to do a couple of other small things, but X-intercepts are the main new idea. So this example is asking us to determine the direction which the function opens, right? Does it open up or down? It wants us to find the vertex, the axis of symmetry, the X-intercepts, and the Y-intercept. And then we're going to use this information to help us sketch our graph. So let's start with the direction this parabola opens. Remember, that comes from the value of A. If A is positive, it opens up. If A is negative, it opens down. In this case, A is positive, so we know our graph opens up. So we know kind of the shape of our graph. Our axis of symmetry, remember we have to find the axis of symmetry before we find the vertex. So the axis of symmetry opposite of B over 2A gives me positive 11 over 2 times 2, or 11/4. Since I'm going to have to be plugging this into a quadratic equation, I'm going to make it easy on myself and change that to a decimal, 2.75. So now on to my vertex. I already know the x value of my vertex. I get that from my axis of symmetry. But now I'm going to plug that 2.75 into my original equation for x to help me find the rest. When I do that and use order of operations and simplify my equation, I get negative 10.125. And of course that then is going to be the y value for my vertex. I still need 2 more items. It's asking me for the y-intercept. Y-intercept is super easy to find if you know where to find C. Since C is 5, my y-intercept is 0, 5. Now on to x-intercepts. You guys actually know how to find x-intercepts now, thanks to our previous unit where we learned to use factoring, completing the square, and quadratic formula to solve a quadratic formula for x. So we're going to zoom out a little bit here so you can see a little better. Here's my original formula, or original equation. I'm going to use factoring this time. You really could use any of the 3 methods to solve for our x values. But when I factor, I get 2x minus 1 times x minus 5. I did forget to mention that I turned h of x into 0. Remember, h of x is our y value. And on the x-axis where my x-intercepts are, y is always 0. And of course, to solve for x, then I set each factor equal to 0 separately, and I get x is 1/2 and x equals 5. Those are the values I can use to find my x-intercepts. My x-intercepts then are going to be 1/2 0 and 5 0. Now I'm going to take all of this information and draw a graph, right? Use this information to sketch the graph. That's exactly what we're going to do. I'm going to start with my axis of symmetry. I'm going to draw that vertical line where x is equal to 2.75. Then I'm going to put my vertex on that line down here at negative 10.125. My y-intercept at 0, 5. And if you will go back and remember with me, we can reflect that y-intercept across the axis of symmetry. When I then draw in my x-intercepts at 1/2 0 and 5 0, I get a really good picture of where my parabola is supposed to be. Now, one more example before we call it a day. This is definitely one that you're going to want in your notes, so make sure to be ready. We want to create a quadratic function or a quadratic equation given only a vertex and a y-intercept. Believe it or not, that's enough information to get the job done. So we're going to first of all go back and remember that the x-coordinate of the vertex comes from opposite of b over 2a. I know that the x-coordinate of my vertex is 2, so now 2 is equal to opposite of b over 2a. I'm going to multiply both sides by 2a. I'll show you why. Because on the right hand side it gets rid of my fraction, my 2a's cancel, and on the left hand side 2a times 2 is equal to 4a. So now I have 4a is equal to the opposite of b. When I divide both sides by -1, I get b is equal to -4a. This little piece of information right here is going to help me out a great deal in finding my function. So let's take that information, and now we're going to start to do some substitution. I'm going to start with the standard form of a quadratic equation, and now I have a value for b that I can use to replace b. So that's where I'm going to start. I'm going to say that b is equal to -4a. Now I have some other values here that are going to help me substitute. Remember our vertex 2 and -4? Remember how 2 is the x value and -4 is the y value? Well, I just so happen to have some x's and y's in my standard form equation. So I'm going to replace all the x's with 2 and all the y's with -4. And finally, I also have a y-intercept of 4. And where does that 4 come from? It comes from c. So I have one more value that I can substitute into this equation. Now I'm going to do a little bit of simplifying. 2 squared gives me 4, so I have 4a. -4a times 2 leaves me with a -8a. And then of course I'm going to simplify that further by combining like terms. 4a minus 8a combines to give me a -4a. So now I have -4 equals -4a plus 4. Now we're going to solve for a. So I need to subtract this 4 from both sides. And then I'm going to divide by -4 to get a by itself. And that's going to give me a equals a positive 2. So now this value for a is going to help me again. I know that b was equal to -4a, and now I know a is 2, so I'm going to do yet another substitution. -4 times 2 is equal to -8, and now I have just a final numerical value for b. So now I have a, now I have b, and what other value did we have? We also had c that came from the y-intercept. Now I have an a, a b, and a c. That is enough to write my quadratic function in standard form. Of course, if it's asking me to write a quadratic function, I probably want to put f of x right here instead of y, but that's kind of the basic skill set. Now I know that that's a lot to take in, so I'm going to ask you to do one thing. I would love for you to go back and watch that last example again, pausing where you need to, so that you can make sure to have those notes and be able to follow those directions. If you can do that, then we'll go through another of those examples in class. I think that's plenty for today. I hope you're having a great time, and I'll see you next time.